All right, let's dive into a biological mystery that's been hiding right under our noses for centuries, literally inside the eye of a bird. It's a paradox that baffled scientists, and the solution reveals a flat-out evolutionary superpower. We all know birds have incredible vision, right? I mean, think about an eagle spotting a tiny mouse from a mile up. Their eyes are these amazing pieces of biological engineering, just packed with light-detecting cells, giving them super sharp, high-def sight. But that kind of power has a pretty big cost. You see, to power that incredible vision, a bird's retina is one of the most energy-hungry tissues on the planet. And any tissue that works that hard needs one thing more than anything else to survive. But here's the puzzle. Bird eyes are missing that one crucial component. So what is it?
Blood vessels. Your retina, my retina, it's crisscrossed with tiny little capillaries that deliver a constant stream of oxygen. Bird retinas? Nope, don't have them. And this is where it gets really weird. Their retinas are super thick, sometimes 4 times thicker than what should be physically possible for oxygen to even soak through. So how on earth are these visual engines not just sputtering out and dying?
Well, for a very, very long time, scientists had what they thought was a pretty good answer. They had a prime suspect for how birds were solving this oxygen problem. If you could peek inside a bird's eye, you'd find this bizarre comb-like thing called the pecten oculi. It's this super dense, folded-up membrane that is just jam-packed with blood vessels. And it kind of looks like it was designed to do one thing and one thing only. The idea was pretty simple and elegant. The pecten works like a little scuba tank. It just steadily pumps out oxygen, which then floats across the eye to feed that hungry retina. Made perfect sense, right? And for more than 100 years, that's what everyone believed. There was just one tiny little problem. No one had ever actually measured it. And this is where the story gets really good. This is the big twist. Because when a team of scientists finally figured out how to measure the oxygen levels inside a living bird's eye, they found something that nobody was expecting. So what happens when you finally manage to stick a super tiny oxygen sensor inside a bird's retina? Does it confirm the 100-year-old scuba tank theory? Not even close. Just look at this chart. On the far end, you've got the outer retina, plenty of oxygen there. But as that sensor moves deeper into the inner retina, where all the neurons are doing the heavy lifting, the oxygen level just plummets. I mean, it completely nosedives all the way to 0. Let that sink in. The inner part of one of the hardest working tissues in a warm-blooded animal is completely anoxic. It's running in an environment with 0 oxygen. In our own eyes, that would cause catastrophic, irreversible blindness in minutes. For a bird, it's just business as usual. And what about that pecten, the supposed oxygen tank? Turns out it provides a measly 0.76% of the retina's oxygen, less than 1%. It's not a scuba tank. It's barely a leaky faucet. The old theory was officially dead. So this amazing discovery just blew the whole case wide open. It solved one mystery, but created an even bigger one. If the bird's retina isn't using oxygen, how in the world is it getting the energy to work? The answer has a fancy name, anaerobic glycolysis. But you can just think of it as the body's emergency backup generator. You know, when you sprint all out and your muscles start to burn, that's your body using this system. It lets you burn sugar for energy without oxygen. It's incredibly fast, but it is wildly inefficient. And the genetic evidence was crystal clear. In that oxygen-free inner retina, all the genes for burning sugar were cranked up to 11, and the genes for using oxygen, they were basically switched off. The retina had completely rewired its own engine to run on a totally different fuel. Now, to make up for how inefficient this is, that retina has to be an absolute sugar monster. And it is. Per square inch, the bird's retina burns through more than 2.5 times the amount of glucose as the bird's brain. It is just ravenous for sugar. Okay, so this brings us right back to our old suspect, the pecten. If it's not a scuba tank, then what is its real job? And how is it keeping up with the retina's crazy sugar habit? The new evidence shows its role is actually way cooler. The pecten isn't an oxygen tank at all. It's actually a super sophisticated metabolic support system. The best way to think about it is as a combination pantry and garbage chute. Here's how this brilliant system works. First, the pantry. The pecten pulls huge amounts of sugar from the blood and uses it to stock the gel inside the eye. Then, the retina burns through all that sugar. But that creates a nasty toxic waste product, lactic acid. That's where the garbage chute comes in. The pecten then efficiently pumps all that toxic acid out of the eye and back into the blood to be hauled away. And on a tiny molecular scale, this whole beautiful exchange is handled by specialized little protein machines. The pecten is covered in what you could call indoors, called GLUT1, that only let glucose in, and outdoors, called MCT1, that only push lactic acid out. It's a perfectly balanced system of supply and disposal. So why? Why would birds evolve this incredibly bizarre, oxygen-free eyeball powered by a high-tech pantry system? Well, it turns out that solving this one little biological puzzle unlocked an absolutely incredible evolutionary advantage. This is a perfect example of something called exaptation. It's a great word. It's when a trait evolves to do one job, but then, millions of years later, it turns out to be absolutely perfect for a completely different new job. By figuring out how to run their retinas without needing oxygen, birds got rid of the need for all those blood vessels. That let them evolve thicker, more powerful retinas with more cells, which meant sharper vision. That was the original advantage. But here is the incredible part, the exaptation. This oxygen-proof system pre-adapted them for high-altitude flight. Think about a goose flying over the Himalayas, where there's almost no oxygen. Our vision would start to fail, but the bird's retina, it doesn't even notice. It was already built to run without air. It's really an incredible story. What started out as just a weird solution for building a better eye turned out to be the key that let birds conquer some of the most extreme environments on the entire planet. It really makes you wonder, doesn't it? For hundreds of years, we looked at this thing and we completely misunderstood it. What other amazing biological secrets are still out there, hiding right in front of us, just waiting for us to find the right way to look?